to conferences all the time is the main driver for progress in your skill set and also your relationship, and basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, and you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really, really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
Hi, I'm Rod Cope, CTO of Perforce Software. I'm in the United States, in Colorado, just outside the Rocky Mountains. And my talk is going to be on how to use continuous testing to go faster with better quality than ever before in your DevOps lifecycle. And I wish I was doing this talk in Vilnius this year like I did last year. It was great, where I learned some Lithuanian. Vienas, do, tri, katra, penke, seši, septyni, aštuoni, devyni, dešimt. Hope that was good enough, and I look forward to speaking with you soon. Okay, are we live? Okay, hi, I'm Rod Cope from Perforce, and we're going to talk about unblocking DevOps with continuous test and why continuous testing is so important. It's difficult, but there are a lot of benefits to be had. It's a key to getting DevOps right. Sometimes it's overlooked. Sometimes people think of test as something that can still be done after development, or it's still manual. It can be the one manual step sometimes in a completely automated CI/CD, continuous delivery, continuous deployment solution. We're going to talk about how to do a better job of that, why it's important, why it can be difficult, and how to make it better. Okay. So as I said, I'm Rod Cope, CTO of Perforce. I was CTO of Rugwave Software and formerly founder and CTO of OpenLogic. So I've been in software for a long time, worked at some very large companies, some small companies, some in between, and I've spoken at a lot of conferences for a long time, including at TestCon in Vilnius last year, and I wish we could all be there again this year. Maybe next time. All right, so we'll talk about why CT, continuous testing, is hard, what it is, who's involved, what are the key elements, what kinds of tools each participant in continuous testing uses, some challenges, some recommendations, things to measure, things to know, are you getting better? Are you going in the right direction? And then finally, tying it all together, some examples of, I think, how to do it right. And then we'll have questions at the end. Okay. So if we take a look at the Agile Testing Manifesto, especially DevTestOps, as we like to think of it, we favor these things. We favor continuous testing versus waiting to the end. We favor all testing activities, not just automated. There still is a good reason to have humans in a loop, mainly for user experience, user interface. We'll talk about that. Testing what gives the most value, not just checking the box to say everything was tested, because some things are less important than others. Why we need to focus on the business value, the user experience. Testing across the entire team, not just in siloed environments, not just with QA departments kind of receiving things thrown over the wall, but testing everywhere from development to QA to the business to people who run user acceptance tests. And then finally, focusing on product coverage, not test coverage, not looking, or code coverage, not looking, for example, to make sure every if statement in the code is actually covered. That would be great, but that's a lot of time, a lot of effort. It may not be worth it. And instead, focus on covering the areas of the product, right? So biggest bang for the buck, as we say in the US. Make sure you spend your effort where it's you're going to get the most reward. All right, so what is continuous testing? So we already have continuous integration, continuous delivery, continuous deployment. Continuous testing fills in this sort of infinity loop diagram, the bottom left corner there, part of the loop, fills in that continuous nature. We're always running tests with every check-in, every commit of code, ideally not just before release, not just every night, but continuously. And the idea is to get a grip on the business risk for a release. Is it okay to ship or not? That's really what it all comes down to. And by testing continuously, we are always in a good position to know, is it okay or is it not okay? We don't have to guess. We don't have to wonder. We don't have to wait. We always know what condition we're in. That's important. It's key to Agile. So how does continuous testing fit in a DevOps formula? You can think of continuous delivery as the result of continuous integration plus continuous testing, right? You don't deliver until all the code is integrated, the builds work, right? The unit tests work, and your continuous tests have run. All your automated tests, whether that's functional, non-functional requirements, user acceptance, whatever you feel comfortable with in your environment. Every product, every team is different, but it's key to make sure that the testing is part of that equation. And the goal we're striving for here, perfection is very difficult, right? And very expensive, very time consuming. So if you can get to about the 90% range for correct tests, right? And again, humans are needed for some kinds of tests. So you can only get so high. You can't get to 100% in most cases. And stable is the key word here, stable test automation. I'm going to touch on this a number of times as we go through this talk, that just having tests, just having an automated test framework or a collection of hundreds or thousands of tests is really useless, or worse than useless if they're failing all the time. If developers and QA people are constantly troubleshooting and figuring out, why did that test fail? Oh, it's a false positive. Ignore that one. Increase the timeout on that web page, right? From 1 second to 2 seconds to 3 to 5 to 10 seconds, and keeps getting worse to make sure that element appears on the web page, for example. These kind of problems continue to happen. Tests are flaky. No one trusts the test. They're not stable. They're worse than useless because now you have to maintain them and you get very little value. You wake up every morning and you get emails with broken tests that the team has to spend most of their time dealing with. So stability is fundamental. All right, so how do we get there? Well, first, stable automation, like I just said. Even if you only have one test and it passes, that's better than having 1,000 tests that fail intermittently and randomly and cause nothing but pain. All right, so you create the tests, your scripts typically, maintain them, understand what's wrong, fix them, keep them fixed, keep them stable. And it needs to be matched to the skill set, right? If the tests are being done by developers, use tools developers are comfortable with. If you have a different set of tests implemented by QA people, use tools, scripting languages, frameworks, reporting tools, etc. that QA people are happy with. If it's business testers, same for business testers. So match what you're testing to the tools that support that kind of testing, to the persona and the people using the tools. That's important. And of course, detect false negatives, false positives, do your analysis. We'll talk more about that. Get to a daily cycle. First, this is on the path to continuous. You can't start there day one. It takes some time, right? So first get stable, small set of tests, then start running more frequently. Run the scripts daily. Get your test results in minutes. It shouldn't take hours. Yeah, there's something wrong in that case. You need to accelerate, use mocks, simplify, do something to make them run quicker so they have more value. Use a lab. This is something a lot of people overlook. That lab, whether that's mobile devices, emulators, simulators, automated tests, whatever it is, it needs to be available almost 100% of the time. Again, for stability, if it's not available, test will fail, maybe intermittently, and cause more problems than they're worth. So, collect your evidence, have ways to view the test live, maybe record, capture video, look at results, integrate into your CI and CD and defect tracking, watch your execution, have dashboards. Those are all the basics, the fundamentals to get in place so you can have a daily cycle that is useful. Then start increasing coverage. Now we're getting into what we think of as a DevOps friendly zone, where you can now start to get some real benefits out of automated testing, continuous testing. So you get valuable coverage. You start to expand, always making sure you remain stable, testing quickly, having the test run quickly. Maybe break them up and run in parallel, whatever it is, keep them running fast, get meaningful feedback every day. When errors are reporting, they're real errors. There's something that needs to be investigated, not just false positives. What you'll need is ways to validate the tests visually. Visual testing becomes important. Orchestration, running tests in parallel, an up-to-date lab. If you have to release on the latest Apple Android devices, make sure you have the devices, make sure they're up to date. They have the operating systems you need to certify on, that the lab can scale up and handle the amount of tests you want to run, that you can have results and analyze results and get to root cause analysis and group similar tests that fail and run in similar ways and to slice and dice those. Now we're getting into the basics of really accelerating with DevOps. Once you get to about 95%, you're automating all that's possible. You still have, again, humans in the loop for a user experience. Like maybe the test passed, but does it look good? Does it feel good to a user? Is it hard to use? Is it friendly to use? Humans still need to help with that, especially as you're adding new features. Advanced orchestration, elasticity, sharding, bursting into maybe a cloud, using a mix of your resources or multiple clouds, controlling the environment, simulating low bandwidth, the ability to simulate videos and fingerprint touches, all those kind of things, scaling up reporting as you really ramp up your team and the amount of tests. Then finally, you get to continuous testing. You're moving from nightly to continuous. Every check-in, every commit, every build for every developer on all the teams. So you're constantly running tests, and a lot of them, so you have very high scale. You're executing in the cloud. It's kind of a necessity to handle this kind of load. And so all your tools need to support that kind of scale from reporting as well as execution and resource availability. So now you've kind of seen the path, how you get there, where this is the roadmap and what you'll get out of it. So the key pillars of continuous testing in DevOps, and this unified solution gets you to great efficiency, has four main pillars: creation, execution, lab, and analysis. So creation, obviously about creating and maintaining scripts, authoring tools, validations, etc. Execution is about running at scale in parallel with orchestration, all the frameworks that you need in your environment, all the different platforms, etc. A lab, this is kind of the backbone for your testing with devices and emulators and simulators and in the right mix, always available, highly scalable with all the functions you need to get access to the results, to see live test, video playback, etc. And then finally, analysis. And this is really important to see if you've got this testing at scale and it's continuous. That's a massive amount of data. You need ways to understand when something gets goes wrong and ripples and causes a bunch of failures, what's the root cause? I need fast analysis. I need to examine what went wrong and run reports and look at the data from different angles. So these are the key pillars of the solution. And this is an essential part of DevOps. And that's really the message here. It's not optional. If you're doing DevOps everywhere else and you've got CI and CD and you're trying to optimize and get to market quickly, you have to have continuous testing. And so that means matching, again, the tools, what you're trying to achieve, to the people involved. And that means sometimes working in a codeless environment, recording visual tests, maybe for business users, for QA people, behavior-driven, acceptance test-driven, etc., open source frameworks, object-based detection, visual automation, all these things are important. And of course, if you're using modern mobile devices, being able to deal with rotating devices and using the camera, using fingerprint verification and unlocking, all those things are critical. Executing at scale with orchestration, with your CI solutions all fully integrated, are critical. Queuing, prioritization, some jobs need to jump to the front of the queue. You need to be able to visualize the queue and have administrators always make sure there's enough resources, sharding across machines, etc., to control that flow. That's key. And we mentioned secure enterprise-grade lab, always available, updated, fully managed, ideally, so you're not constantly dealing with devices that overheat or that lock or that need to be rebooted manually. Right? All these problems slow you down. So ideally, you have a managed lab where you don't have to deal with any of that. Somebody else is responsible for it. Collect all those artifacts, the test results, the videos, did something lock, right? To know what went wrong without physically having to go to the device, and implement all those environmental controls. We'll talk more about that too. And then finally, analysis, single pane of glass, one tool that collects from all the test executions, whether that's business users recording codeless tests or developers writing unit tests, QA people doing functional tests, something in between. One pane of glass to see it all, to triage, to group, to get rid of the noise and the false positives, and to scale to your needs. Okay, so now we've kind of set the stage. So who are the people involved in continuous testing? What are they doing? How can we optimize? So three main personas. We have a business tester doing that exploratory and manual testing to look at the user experience, the workflow, the UI, looking at new features. What do they like? What do they not like? Making sure that they understand how a real user would use the app they need to sign off on. Is this good enough? Then we have software development engineers and tests that are creating functional, non-functional tests, typically code-based, right? Selenium, Appium, Espresso, XUI tests, those kind of things. And then we have software developers typically focused on unit tests, build acceptance tests, definitely code-based, highly automated. And so some of the challenges we face with these personas are getting the right mix, right? So if you look at the left side, kind of that code right after planning, developers running unit tests, they want fast, lots of churn, lots of code change. They need quick feedback. So they want to have a high mix of emulators, local devices, plugged in, maybe 10% in the cloud. They're writing unit tests. They want things to go fast, pre-commit, maybe a few minutes, they're running on demand. Then in a build environment, we want a different mix where we use maybe more cloud, more real devices to start getting that early feedback. Okay, maybe it works in an emulator, but a real device would have problems. There's lockups and timeouts and contention for resources and all kinds of other things that happen in a real device. Right? Different set of test frameworks. Tests run a little bit slower, don't run as often. Then we have a QA type environment where you want to use real devices in the cloud. You don't want to run these locally or manage them locally. And only real devices matter, because if you sign off on the app, it has to work in the real world. Emulators doesn't do any good if they pass there and fail in the real world. So different kind of tests, again, can run longer, not quite as frequently, a little bit slower. And then finally, in the real world, it's all real devices, all running, simulated with high-level tests, and you want to run those all the time, ideally in a real production environment your customers are. So where does this leave the business tester? Where does manual fit in, codeless, behavior-driven development? This kind of traditional model is unoptimized. I think optimizing for these personas, you give the right people the right kind of tools. So on the left, with the developers and engineers writing tests, that's code-based. They use the standard tools. On the right, you have business testers writing codeless tests, recording, using BDD tools, describing, declaring what they want, and then focused on user experience and UI tests manually. That's where developer or business users want to spend their time. What does the real world look like? And so you need a tool that combines all these things under one roof and gives you a collaborative approach where you have both codeless and code-based developers, QA people, and business people can all run the kinds of tools, the kinds of tests that make sense for them, yet see all the results in one place. And that can help troubleshoot and point out areas where maybe you have things working well in development, not so well in tests that cause people problems in the real world, and in the business users are having issues, or vice versa. Maybe the recording and playback and getting results for the business users are good, but there's a lot of churn on a development side. You have broken tests, and they're slowing you down. So one pane of glass to get all those results and to be able to control it all in one place and prioritize is important to have an optimized approach to continuous testing. All right, so now let's look at some of the challenges and suggested fixes, workarounds, recommendations, how to measure, are you doing the right things? Are you getting better? So the big blockers to DevOps, right? Some automation challenges. Testing is really the key. It's the missing link in the whole DevOps picture of going straight from a developer writing code to it's in the hands of real in-world users. You want to make that as seamless as possible. Testing is still the biggest bottleneck. And a lot of the issues why, less time to automate. It's still considered an afterthought in a lot of cases. It's something that's a nice to have. And features are more important. Security is more important. Something else always takes priority. Automation, because you maybe have broken tests, nobody trusts them. It's a waste of time. You spend less time automating writing tests. Or going around to left skill set mismatch. You have the wrong kinds of tools for the wrong kinds of people, right? QA people, business people need codeless. Test maintenance, we mentioned it. It can be a huge burden. Sometimes teams spend upwards of 75% of their time dealing with broken tests and maintaining tests. That's too much. It's not helping, and it's generally because they're unreliable. They are suffering timeouts. Devices are locking. Lab's not available. You're on old operating systems or older devices, or you don't have the new ones, or you don't have all the ability to test all the browsers on all the operating systems, and you get certain browsers, certain operating systems that fail more than others. They tend to get ignored, which causes more problems, and it snowballs. And then finally, unoptimized execution takes too long. If it takes a day to run your tests, everybody's moved on, and then they see the test that failed and nobody wants to work on them. So these are the big blockers. Talking about less time and tighter release schedules, release schedules keep getting shorter all the time. You try to do more with less and focus more on security, maybe on the user experience, other aspects of development. Times are getting tighter because you have to get to market faster than ever, less time for testing. So consider acceptance test-driven, behavior-driven, codeless practices to focus on the biggest value. Be consistent with CI integration. Eliminate the shadow CI and the testing teams doing their own thing because the bulk of CI is broken or so heavy or slow. or unreliable, that there's multiple efforts in parallel to do it right. Try to avoid that and have one consistent unified process, unified set of tests that work. Adjust the test pyramid. Focus on the things that run fast, that are valuable, that work well, that are reliable, and minimize the others. If you have to get rid of them for a while, get rid of them and then slowly grow back reliable, trustworthy set of tests. And use faster frameworks, the ones mentioned there, headless testing, Puppeteer, things like that. Get them to run fast so you can fix the problems fast and stay in the flow. You can see on the right, usually as you go up the stack, it's a little slower, you have fewer, heavier tests. The ones at the bottom run faster and can be more reliable. So have a balance in your testing portfolio. Get value, but make it trustworthy and run fast. The lack of stability causes so many problems. You have to continuously maintain your test as you maintain code. It's just as important. It's not an afterthought. It's not second. It's on par with. It's production level code. Those tests are critical. If the tests break, it's like features breaking. So break into sub-test suites if necessary, so they can run at different speeds. When certain parts of the code base change, you only run certain tests. Whatever you need to do to run in parallel to go faster, make them work. Have agreed upon KPIs, key performance indicators, to know, is this going the right direction? Are we getting value out of these tests or not? Stabilize the environment. Make sure you're always ready. The tests are always reliable. You don't say, well, they're going to be broken for a while, then we'll fix them, then everything will be fine. That's a recipe to keep putting off that technical debt. It keeps getting worse, and they never work. Okay, if your execution isn't optimized, isn't intelligent, it can get slow, it can get heavy, it can get ignored. And some things that can help with this are things like machine learning type approaches for optimization, codeless tests that are more resilient to changes. Small things change in UI, a button moves, label changes, color, CSS class, ID, whatever, and it breaks a whole bunch of tests. Try to use tools that are more resilient to those kind of changes, more reliable. So you don't always have to manually fix every one of those when something small changes or could break. Refactor, use tagging, analytics hook, other things that help you debug. So when something goes wrong, you can very quickly troubleshoot, get to the root cause. Again, treat test code as production code. It's code. It has to be maintained, versioned, reviewed, use best practices, automate, bake it into stable CI, stable pipeline. You can use pairing in coaching and mentoring, just like other code is written in the development world. Pick good object identification strategy. Is that CSS class or ID or location or a framework generated ID or location in the DOM? Talk about that. Figure out good strategies that are shared across the team. Leverage best practices. Don't have every developer figure it out on their own or every tester figure it out on their own. Measure efficiency. Is it working? Focus on the most important areas of the product, the most highest levels of risk, new features, for example, or very sensitive features, sensitive data, high scale, high throughput areas of the code or features are most important. And do continuous data analysis and improvement. Right? Look at how things are going and think about the big picture. Where should we focus the next set of testing activities instead of just randomly distributing test effort across the code base? So some recommended measurements. How fast your test is critical. They can't, if they take too long, they tend to get ignored. People moved on. You're out of the flow, you're working on something else. You don't want to be interrupted when those results come back. So make sure they don't take too long. Flakiness destroys the value of the performance. If they're fast and flaky, they're still useless in a lot of cases. So measure How much automated test, how much manual test? You want that automated number to be in the 90-95% range if you can get it. Quality, how many escape defects? That's where you need to spend your time. If these are regression tests affecting real users, that's where you test more. Mean time to detection, build quality, things to measure to know, are we getting quality right? Is testing actually helping the business? Pipeline efficiency, how many stories are we getting done? Is testing automation part of the definition of done? Right? Can you make sure that it's not just good enough to say the feature works? It's tested manually, but it's tested in an automated fashion as much as possible before the story is done and delivered. Broken builds with categories. What caused this build to fail? So keeping track of that. Are your CI builds getting longer and longer and longer over time? Or are they remaining stable? Are you doing work to keep it down? Lab availability. Have you overbuilt? Have you underbuilt? Are you taking too long with test waiting in the queue, for example? And in quality cost, how much is it costing us to run our lab, to update, to buy devices and maintain hardware and do the installation? How much people time do we spend keeping everything up to date and maintaining the tests? How much are defects costing us, etc.? So there's 4 metrics: speed, quality, efficiency, and cost. Those are things to look at across the board to see, is continuous testing happening? How well is it going for you? Is it the right thing to do? Where do you spend your time, effort, and money? So smart continuous testing, I think, comes back to those 4 pillars: creation, execution, lab, and analysis. Creation is about highly productive web and mobile test automation. That's the ability to have code list that is resilient to changes, so it doesn't break every time some little thing changes in the UI. To be able to run all the test frameworks you need, to have the different personas use the kinds of tools they need, codeless and code, with all the capabilities that you expect in modern devices today. Rotating devices, Touch ID, fingerprint, face recognition, image injection, video and audio injection, location mocking, dealing with bandwidth constraints, and to test under all those kind of combinations needs to be part of the tool, part of the test creation and maintenance. So it's possible to write tests that take advantage of all these things, because this is what users face in the real world. You have to test in those environments to still have interactive manual testing for user experience, user interface, to make sure that the end result is good. Remote device access. All these things are critical when you're looking at the creation and maintenance side of testing. On the execution side, it's important that they run fast, that you have the ability to burst to that elasticity. So when you have a massive amount of tests to run at once, it doesn't take days to run. You can run lots of things in parallel with all the frameworks you need, with queuing, prioritization, parallel test execution, and the ability to ideally visualize those tests running. So you can drop in on a running session, see the screen of the device, the web browser on the actual operating system with a version of the device. So you can see, is it working? What does that look like for a user? Are they having a different experience when something goes wrong? To be able to very quickly troubleshoot and to see through the eyes of what the end user would see. All that's key to your execution. And to execute right, again, with the real world in mind, you have to have a lab. And that means secure, highly available lab that's up to date with, if you're a major software development company, or your customers, your clients are global companies, you need a global presence. You need to be able to run and simulate devices on different carriers, different networks, different parts of the world. So you can look at latency and performance and all those kinds of things in different networking conditions. You need smart healing. When Wi-Fi drops, can it reconnect? Anti-locking, overheating, all those kind of issues you have to deal with devices being used heavily. network emulations, and coverage, collecting all the artifacts, whether that's log files, videos, other metrics that you can collect and visualize all in one place without going to the devices. And then again, to have a fully managed outsourced lab, if you're going to go that route, needs to be quick. Right? You want a fully managed service, and you also want access to new devices as they come out. I mean, ideally, the day they come out, like the new iPhone 12 just announced, it's going to be here next week. You want a lab that can give you access to that as quickly as possible, so you can test and see, did anything go wrong before a bunch of new users use your code and find out there's a problem. And then analysis, also critical, because once you've run all these tests and you do it in parallel, codeless and code, and you've got a lab, if you can't visualize and see the result of all that work, it doesn't do you a lot of good. So you need to know, for example, what's going wrong when something goes wrong, to be able to quickly triage. Is it a scripting issue, a framework issue? What's wrong with my scripts? Did something happen with the test itself because something changed and broke it? Am I not accessing the objects in the right way? Did the DOM change, for example? Is it a backend issue? Is it a server problem? Is it a device is not available? There's a problem with the network or the Wi-Fi, or the data is not what we expected it to be. Or is it something with the lab? Is the lab unavailable? Is it flaky? Is our network issues getting to the lab or inside the lab? Is it not configured correctly? Am I having too many locks on devices or other things? Or is it an orchestration issue with executing? Do I have too many devices in use? The queue is too long, or I've disconnected. I can't get access to certain devices, or I don't have enough licenses, maybe on one of the test tools in the chain, or for some of the devices, and they're being they're not available to my test due to a licensing issue. All these things are critical, and you need to know very quickly which things went wrong and how, so that you can do something about it. And as we mentioned, you want to have as much as possible under one roof in one environment, like with a Perfecto dashboard, where you can see all the different projects with the different teams. What are the results now of the last build, current builds, trends over time in terms of duration, test passing and failing, both code and codeless for all the personas, with the ability to do that slicing and dicing and triaging when something does go wrong. So key components of this, what we think of as continuous testing visibility, to have access to what's happening in a complex environment. Executive overview throughout the process, in real time and with trends. And this is important not just to the individual developers and testers, but to team leads, to managers, directors, people looking across the project and across multiple projects to see what are the trends. Do we need more resources? Do we need to focus resources in a different area to get better results? Heat map type dashboards to focus on the most important areas of the test. Are there emerging areas that are causing problems? Maybe a new set of features, new set of devices or operating systems, or a new customer you brought on. And that's where you need to spend testing effort. You need to be able to very quickly visualize and isolate and figure out where to spend the time. To visually verify across platforms, any functional UI, UX issues, works on one browser, doesn't work on a new device. For example, to visualize and compare side by side, so you can see very quickly, here's a problem, here's where we need to spend effort. And to let anyone on the team quickly get access to that through one dashboard is key. Noise reduction, you automatically detect and classify, hopefully with AI like we do with Perfecto, if there are errors, failures, to group, like for example, an issue with login caused a ripple and lots of tests fail. Okay, you want to instantly kind of isolate and group those into one major area of a failure, not 100 individual things to investigate. Single test reports with root cause and a rich set of artifacts. Anything that helps you diagnose the problem and look and fix it quickly is important. in a report library. So you can triage, you can slice and dice this big data when you have lots of teams, lots of projects, different tools, different personas. You need to come at the problem from different angles to see what's working well, what's not working well, where do we go next? And so we bring it all together in Perfecto with what we think of as a smart continuous testing solution that combines the creation, execution lab, and analytics in one unified platform from the ground up, one dashboard that lets you run all the different types of tests that you have, all the different major open source frameworks, with that world-class lab that's always on, always stable, always up to date with the latest devices, with all the major operating systems and versions and platforms, so you don't have to manage and deal with any of that, with the ability to run in parallel quickly with that cloud bursting capability in parallel, of course, with all the analytics you need to support millions of test results, and that could be millions of tests every day that you run in your company. And we did this for many of the largest companies in the world have trusted our scale. And we have support, management, training, and of course, experts in testing have been doing this for a very, very long time and know where the problems are, how to avoid them, and how to optimize. So whatever solution you choose, these are the key components. That creation, execution, lab, and analytics, you want to look for one unified solution as much as possible. And with that, I think there's a few minutes left for questions. And let's see if we have live questions, and we'll also be available. I'll be available through the app and ask me anything afterwards on Zoom if there are other questions. So let's see, let me check the app. Okay, so we got some questions coming in through the Slido app. So one question, any advice for a situation where there's a lot of technical debt in terms of missing unit and API tests? And that's a common situation, especially for an application that's been around a long time, a legacy app. Maybe you're adding APIs or trying to retrofit or move to microservices. There can be a lot of technical debt. I think just as if you're starting from scratch with a new project, the idea is don't try to boil the ocean. Don't try to create tests for everything all at once. It's too much. Like you said, there's too much technical debt, maybe too many broken tests already. So start somewhere small. What's the biggest bang for the buck? Where's the most risky area of the app? So if something were to go wrong and it would do the most damage, maybe the biggest impact on your brand reputation, or it would hurt the customers the most, they would lose money, something would go wrong. That's where you focus and say, here, this area, maybe this API, this section of unit test is related to the parts of the app that fail the most, or we get the most production reported errors or issues. That's where you spend your time first. Implement a handful of tests, make sure they're stable. They're not flaky. They run all the time. They can be well trusted. So they run, every time they run, they either work, or if they fail, there's a real problem, not a false positive. Then go on and slowly expand, looking at the next most risky part of the app or the APIs. So start small, always build upon trust, and grow slowly from there and increase your coverage. And if you do that, I think you'll quickly get to a good place where at least the most important stuff is tested and working well. Another question, is there any hope that enabling manual QAs to automation will be a priority? I think that question means if you have a heavily manual environment today and it's working, although maybe it's slow and it's painful and it's not optimal because it's taking away from your DevOps flow, but it works, can you convince management to start automating? It's a challenging situation, especially if you've got maybe, like with the previous question, a large application with a lot to test and there's no automated test, that can be hard because it's so daunting when you first start. It's like there's too much we don't even want to try. I think the key is to find out where are things breaking, where are they going wrong. When you get reports from end users, from customers and into production application, are they in certain areas of the app more than others? That's where I would say start there, start small. And yeah, it will seem like a lot of work for very little reward, because a lot of people will say, well, we don't have any areas that keep failing all the time, or it fails rarely. It's not really worth automating. That may be the case, but if this app is going to be around for a long time and continue to get new features and new customers and grow, you don't want to be in a situation where you're stuck testing manually and only manually forever. So you've got to start somewhere, start small, start with the highest priority item, get a small set of trusted tests that work and automate, and slowly stop manually testing that area so you can focus your manual test on the next most important area, then automate that and keep doing that over time until you get to a point where you feel like there's a balance. There's enough automated to make us feel comfortable, and we can go faster and feel more safe about changing certain areas of the code that maybe usually break things. Once you solve some of those problems, maybe you've got enough automated testing in place and it's okay, but you'll be in a better situation than you are now. That would be my advice. Okay, and I don't see any more questions right now. Looks like we've answered the ones that are there. So I think we'll close this and then continue to look at the app and move over to Zoom for the Ask Me Anything corner and see if there's any other questions from there. So thank you very much.